Welcome, ladies and gentlemen. So what I'd like to do is show you how to apply some operations when using like the magnitude as well as the dot product. So basically in this first example here, I have the magnitude of u plus v. So basically what we're going to be doing is, following the order of operations, we're going to add our vectors u plus v, and then we're going to find the magnitude of that resultant vector. So first thing we're going to do is I'm going to kind of put in parentheses, even though you don't really need parentheses in there, but I'm just going to write my vectors in component form. For me, it's a little bit simpler to kind of view and understand. And then w, so I have -2, 5. Okay, and I put the parentheses just to kind of remind myself and you to follow order of operations. Add the vectors first, then find the magnitude. And I wrote the definition of a magnitude up above. But remember, we're dealing with different vectors, so that is just arbitrary v. It could be a magnitude of any vector. So by adding these two, again, we're just going to do, remember, you add the first two components, and then you add the second two components. So I'll just show my work here. OK. So therefore, 3 plus -2 is going to be 1. 1, and -4 plus 1 is going to be 1. OK, so now I'm basically finding the magnitude of this vector. I didn't give it a name, so let's maybe call all these vectors z. So therefore, I can use some notation. OK, so therefore, the magnitude of vector z is going to be the square root of 1 squared plus 1 squared. Right? Square the first term, square the second term, which is just going to equal the square root of 2. OK, now in this example, it's basically the exact same thing, except I am finding the difference instead of the sum of the two vectors. And then at the end, once I've found the magnitude, I need to multiply it by the scalar 3. So I'm going to kind of do my work here a little bit quicker. I'm not going to use my parentheses, but I am going to make sure that I write out my vectors here first, because I think that's one of the more common mistakes students make, is right off the bat, v, -1 plus 7. And the reason why I'm going to do that is I want to make sure I distribute. Actually, you know what? I'm going to do this together. I'm going to do this, not in my head, but I'm going to do -2 minus a -1, which is be adding. So that's going to be -2 plus 1. And then 5 minus 7. So rather than showing all of my work, I'm basically just rewriting the terms together. Again, you only subtract the first components and subtract the second components. So therefore, I have now my resultant vector is going to be -1, -2. OK, now before I multiply that by a factor of 3, I need to find the magnitude. So it's going to be 3 times -1 squared plus -2 squared, which equals 3 times 1 squared is 1, 2 squared is 4, so that's going to be square root of 5. So there you go. All right, so now we're going to do magnitude with the dot product. Now remember the dot product, I didn't write that up there. If you have two vectors, u dot v, you're basically going to multiply the first two components and then add them to the product of the second two components. So what we can do in this case is we can kind of do the two operations separately and then add them at the end. So I have the magnitude of u. So we're given u here. So magnitude of u is basically just going to be the square root of 3 squared plus -4 squared. So that's going to give me 9 plus 16, which equals the square root of 25, which equals 5. Then to do u dot v, that's basically, again, going to be, actually, let's write that out. Let's do u, 3, -4, dot v, which is -1, 7. So therefore, the dot product is going to be 3 times -1 plus -4 times 7, which equals -3 plus, that becomes -28. So that equals -31. So therefore, magnitude of u plus the dot product of u dot v is equal to 5 plus a -31, which is just going to equal a -26. and I'll put a little square above that so you don't miss it. In the last example here, we have, now we're doing the product. So we're doing the product of the magnitude of u times the product of the magnitude u dot v. Well, again, just like how we did here, find the two values separately and then apply the operation. So not to waste time, we already know what the magnitude of u is. That's 5. We already know what the dot product of u dot v is. That's negative 31. So all I'm simply going to do is do 5 times negative 31. So 5 times 30 is 150, right? And then 5 times 1 would be 5. So that's going to be equal to negative 155. I'll have to cheat just to make sure. Negative 155. I don't know why I checked my calc there, but I always don't want to make a mistake and then I have to redo the whole video again. So that's it. But there you go, ladies and gentlemen. That is how you apply operations with magnitude as well as the dot product. Thanks.